Tom Donney here. I want to look at a couple things real quick, just for fun. Here's a Saab, my piston for a 70 millimeter. How do I know or 71 millimeter? The last four digits tell you 71 millimeter. Here's a little motorcycle piston, and it's 47 millimeter. And you look at the similarities. This is a modern 2018 piston. Here's our new modern piston to update our antiquated ones from the 50s. We have two rings. The rings are 60 thousandths thick. This is probably a 40 thousandths thick single ring used in racing. And what you do with these little guys, these pistons are, I don't know, probably $1.25 each. And you run it so many races, you just pop the jug off and throw a new piston and ring in there, and away you go, because the one ring will wear out quicker than two rings would, of course. But there's so many similarities here. We have weight reduction on our piston right there with a hole on each side of the piston for weight reduction. And you look at this little guy, guess what? It's got the same thing, weight reduction drilled in it. So that's kind of cool. And then it's got the coating on it, of course. And it's just, the similarities are so cool to think that this piston is really as modern as it is, as we've been able to make it. We look at the cylinder head. Saab cylinder head. Here's a little two-stroke cylinder head off this motorcycle. And guess what? It's got a Hemi head with a little squish band in there. And the thing to remember on your squish band, it's got to be bigger than your piston. You'd be shocked if I told you some of the guys in the U.S. that have built engines and have not relieved the squish area in the head. And then, of course, the piston will come up and make contact every 120 degrees, since it's a 360 revolution. Anyway, I just think this is really cool, the similarities in it. And what I want to show you here real quick, this is the cylinder, and on the back of this cylinder is a movable exhaust port. So this port is actually going to slide up and down. When we grind or when we port an engine, we're going to cut that away, see it going up, so we got a much higher exhaust roof. That's going to be better for higher RPMs. The lower the roof, low RPM, higher the roof, higher RPM. So what the motorcycle manufacturers did here is they added a little valve on the side, or a little lever, and now they can just take and run that so that they can change the port timing on the exhaust to better suit where you run your engine. So wide open throttle, we open it up. Lower RPMs, when we want some more torque, we keep it down, and taken off from the start, we want it all the way down. So that's just pretty amazing. You can do this on a water-cooled engine, pretty tough to do, or excuse me, on a air-cooled engine, pretty tough to do with water, because we got to get everything to seal. The other thing to look at real quick is the transfer ports. We talk about the Saab engine being transfer port deficient. Well, if you look at these transfer ports, there's 5 of them. So we got these 4 massive ones right here. And one of these is probably the same size as the Saab. So this is 47 millimeter bore. Here's a 70, and guys take and put 74 millimeter in these things. The thing you don't realize is the bigger you make the piston, the less air is going to flow, okay? Because your transfer port is going to limit what you do, how much air you bring in. At the end of the day, your engine is nothing more than an air compressor. If you can't get air into it through your intake and through your transfer, doesn't matter how big a piston you put in it, right? You're not gonna gain what you think you're gaining. So that's why you can get by with a smaller piston, with when you change your piston to transfer case air ratio. Small piston, high ratio is good. Big piston, small air movement, that's bad. So that's why we can put out, if you made a modern 71 millimeter motorcycle engine today with 5 transfer ports or 6 transfer ports, whatever, it would way outproduce what a Saab engine could do, because we can move the air through, and we make our air pump, our air compressor, make it more efficient. So the similarities are still all there between what we did back in the 50s, and it's neat to see the progress of our new pistons and how they match other pistons that are being made today for modern engines. But it's also easy to see, why we are so power deficient based on our engine size. And this little movable port is just, I think that is just too cool for school. And they have this on motorcycles and you know, jet skis, and obviously motorcycles, and you know, if we could convert ours to water cooled, maybe we could add one to an old Saab and really have a lot of fun. Anyway, just some things to keep in mind while you're working on your two-stroke and having fun. This is Tom Donney from Fort Dodge in Sturgis, signing off.